Good morning, good evening, whatever it is, wherever you're YouTube. Well, it's an absolutely horrible, grim, rainy, windy day here. There's just been a major storm pass through London. It's caused quite a lot of damage, but I've got away scot-free because I'm just outside London, so a little bit north of there, so it's not a problem, but definitely not biking weather. But next week's going to be really nice, and the Lexmoto is actually coming up to needing its MOT again, so it's booked in for next Saturday. But there is a small issue, and basically we did a run down to Cornwall tail end of last year, and on that run my headlight switch failed, and it's not a big failure. We managed to rewire it so the headlight's permanently on, and the intention was come MOT time. At the moment the problem is that you can turn the headlight switch off, that will turn the tail light off but leave the headlights on, and that's an MOT fail. So we could either put another switch on, and the problem is that's just at risk of doing the same thing again, or the other option is to lock the switch into the on position and then wire the pilot light into something else so that's permanently on as well. Then all lights are on all the time and can't be turned off, and that is an MOT pass. My problem with just simply changing the switch is the same problem is going to come back again, or could potentially come back again, whereas this is a permanent fix. So what we're going to do is make a little 3D printed block that goes in place of the normal switch. That will hold what's left of the switch, the remaining parts of the switch in the on position, and also mean there's no physical switch, because if there's a switch it's supposed to work. So we're going to block that off, put a 3D printed part in its place, and then we're going to rewire the pilot light, and I found a suitable feed that will allow that to be permanently live with the dashboard lights as well. So only a little bit of modification, and it means that's a problem that simply won't come back. So first things first, got to make a model. Okay, so this is our model. It's nothing complicated. I won't go through the process on how we're modelling it. What I've got to do now is save it. We're going to save it as an STL file, which is stereolithography. That's the best type for a 3D printer. So as we go through and save this, and we're now going to import this into something called a slicer. And this is a piece of software. It comes with your 3D printer. And what it does is it basically converts this STL file into something the 3D printer can recognise. You can choose things like layer heights, and if you're going to use additional adhesion and so forth. So we're going to slice it, then this is transferred onto an SD card that goes into the printer. Time to get printing. Right, so this is our headlight switch. I've already cut the end off this because I don't need it to go all the way through, but at the moment, of course, it can move. I don't want that to happen. So we've got our 3D printed part. I don't know if you can see that there, but there's a raised section that matches to the side, then a hollow section which matches the switch. So I can just lift this away. You see that's going to sit, oh, it's difficult to do with one hand available. That's going to sit in there. And that just fits neatly in there. It's very difficult to use a phone and do it. There we go, just like that. So I'm just going to put that with a bit of adhesive. That then just blanks off the switch. There is no switch, therefore not an MOT fail. So that's the switch blanked off. We'll just put this back together, and then we'll get on with the wiring. Right, with the clocks out of the way, what you can see here is this is side light bulb. I've replaced that with an LED because I want to reduce the amount of draw, and we have the green and the brown with the trace. And if we go to the back of the clocks, we can see lots of these greens, they're all earths, and then we see solid browns, these are going to the instrument clusters, and then where we've got here, you've got browns with other colours, that's because they're warning lights. So we're going to take one of these browns and replace this brown feed with it, because the green's going to go to earth. That's fine, we've got continuity there, so it's just going to be moving a jumper wire from the clocks onto that. So first thing to do is do a bit of cutting and splicing. Okay, so this is the wire I'm taking my feed from. So I've got my new wire bound in to the existing brown, and this is going to be the continuity. So I'm going to tin this one, tin this, solder it, put a bit of heat shrink sleeve around it and shrink that. That will give me my completed lead. and then I'm going to introduce the earth back from here where it came from originally. And what's going to mean then is that when this is switched on, which will be all the time that the engine's running, whether it's on high or low beam, that will then send the positive through to the LED bulb. The reason I didn't take a feed from the headlights is because I want the pilot light running all the time. So I don't want a situation where if you go into high beam, the pilot light goes out. It's a supplementary light, it's perfectly legal. I'd rather it just on all the time. So by using an instrument cluster bulb, that's going to be fine. I'm using an LED to reduce the draw as much as possible, so it's only going to be pulling an extra watt, so it's no problem for the wiring at all. Right, that's our splice soldered and heat shrunk. What I'm going to do now, just to improve things even more, is just bind that back into the loom with a bit of insulating tape, and this is now going to be our new feed to the pilot lights. This is now switch will always come on with the instrument lights. Right, so this is the old cable that goes into the loom for the pilot light. So this is the earth, so we want to keep this one. It's only the positive we're taking away. Now, as you can see, I've already got a crimped on connector. This is a Super Seal automotive one. So this is going into number 2 slot. Oops, sorry. This is going into number 2 slot here. Let's see if I can get this in a position where you can see it. Again, always difficult. I can't, unfortunately, so I'm just going to click this in here, and you'll hear it click when it locates. Try and get this in sharp. That's located, that's through, that's locked in. So now all that's left to do is move this silicone seal up to location and put the plug connector in the front, and then we're going to put the other half of this onto the pilot light, and that should be everything. So the final bit with these Super Seal connectors, you can see the 2 pins are in, is this little red locking piece. This goes in the end. So you'll see that that goes in there. You just push this home, and that's now locked completely in position, ready for the other half. So that's one half of our connector. Right, so that's the other half of the Super Seal connector on the lamp holder. This will connect to this end, and that's given us a proper IP connection. It's worth noting, I don't know if you can see there or not, you can just see them. Super Seal connectors are numbered, so there's no particular standard, but as long as you use the same number on each side, you're fine. So I've used number 1 as positive, number 2 as negative. So this is now spliced into the clocks. This goes back to the negative on the loom, and this will leave us with a permanently lit LED pilot light. So just before we bolt everything up completely, I've just plugged the electrics back in. We should, in theory, have, and we do, an LED pilot light, and that will remain on whether in low or high beam. So that is exactly what we want. We still have instrument lights. Job done. If you like these videos, hit the like and subscribe buttons. Sorry about all the shaky camera work. Obviously the primary reason is to do the job, not to film a video. But we're going to have plenty more coming up soon. In the meantime, smash that like and subscribe button, and see you soon in another video.